Good evening, everybody. It is in fact Wednesday, May 27th, and this is Nighttime Mathematics Radio. Format of the show is always exactly the same. All you have to do is tweet questions into Night Math Radio, and I'll try to answer them live on the air. So, take a break here for the first minute or two for people to tweet questions in. If not, we'll go on to the question we've got, which is a question about basic trig functions. Why are there six? How do we use them on triangles? This is Nighttime Mathematics Radio. See you in about a minute. Welcome back to Nighttime Mathematics Radio, everybody. Well, taking a quick look at Twitter here, we've got... Let's see what we got. Got no new questions for the night, so let's look at what we've got. Someone's asking about basic trig functions. So what are these things for, fundamentally? How do we use these, not with the unit circle, not to do oscillations, but how do we use these just to do basic triangle questions? Let's take a look. Well, the basic idea of trig is this. Let's look at basic right triangle here. And suppose we know one angle other than the right angle. We know this angle. This is 90 degrees because it's a right triangle. Then suppose we know some other angle. I don't know what it is, so we'll call it something. X degrees. Well, once you know that angle, you know the third angle. Because remember, the three angles of a triangle have to add up to 180 degrees. So whatever this is, it's 180 degrees minus 90 degrees, because we've already dealt with 90 with the right triangle, minus x. So this is just 90 degrees minus x. So once you know one angle on a right triangle, you know all three. That's important, because if you know all three angles of a triangle, you know it down to similarity. You don't know exactly what triangle this is, but you know what triangle it's similar to. It's similar to every other triangle with these angles. What that means is we don't know the edge lengths, but we know the ratios between them. So whatever you call these three sides, and just to be silly, or to make things easy, I'll call them O for opposite, for the one that's opposite the x degree angle, A for adjacent, and H for hypotenuse. Well, the question is, well, we don't know what O, A, or H are if all we know is the angles, right? They could be anything they want. But we know them down. We know the ratios between them. We don't know O and we don't know A, but we know O divided by A because it's got to be similar to another triangle. We don't know whether it's this triangle or a gigantic triangle that's bigger than the page I'm trying to draw it on, but we know the ratios. We know how big O is compared to A. So what angles can we possibly have? What ratios can we possibly have? Well, there's got to be something in the numerator, so there's three possible choices. Either O is in the numerator, or A is in the numerator, or H is in the numerator. And once you've chosen the numerator, there's two possibilities for the denominator. If O is the numerator, then either the denominator is A, or the denominator is H. If A is in the numerator, then either the denominator is O, or the denominator is H. And if H is in the numerator, then the denominator can either be O or A. So which of these are important? And the answer is, well, all six of them. Every one of these things I've written down here is a function that has a name. And what do I mean by it's a function? Well, it's a function of the angle. Once you choose the angle, you know what all these ratios are. And they all have special names. What is opposite over adjacent? That's called the tangent of x. What is opposite over the hypotenuse? That's called sine of x. What's adjacent over opposite? That's called the cotangent of x. You know, so it's very much like a tangent, except now the opposite one is in the denominator and the adjacent sides on the numerator. How about adjacent over hypotenuse? That's called the cosine of x. Okay, what if the hypotenuse is the numerator? What's hypotenuse over A? That's hypotenuse over opposite. That's called the cosecant of x. And finally, what if it's hypotenuse over adjacent? That's the secant of x. So every one of these possible ratios has a name. Well, that's great. We know their names. How do we use them? Well, the answer is, suppose we know an angle. Let's look at a concrete problem. Let me move it up so it's inside the range of my camera. Let's look at a really concrete problem here. Suppose the problem looks like this. Suppose we have, suppose we know this side is 12. This is a 24-degree angle. Here's a right angle. And we want to know what x is over here. Well, the trick is this. There will be a trig function which has the thing we want to know divided by the thing we don't know yet. So, for example, here, you notice we would like to know x, we know, which is opposite. We already know adjacent. So what we need to do is take a function that's opposite over adjacent. What's opposite over adjacent? That's tan x. So tan of 24 degrees here is equal to x divided by 12. And now we can multiply both sides by 12. 12 times tangent of 24 degrees is equal to x. And now at this point, we pull out a calculator. Because tangent of 24 degrees is going to be something you need to know. So let's pull out a calculator here. So here's a nice calculator. Let's make sure it's set in degrees mode. And there it says deg down in the bottom. Right there it says degrees. So we're in, right there. So we're in degrees. So So we want tangent of 24 degrees times 12. And it very quickly gives us a nice approximation. This is about 5.34. Oops, not degrees. 5.34 is the length. I'm losing my mind. And that's a trick to essentially every problem that looks like this. If you know the angle, you know one side, and you don't know, what you do is you say, okay, some trig function of angle is equal to side we don't know divided by side we do know. And then multiplying both sides by side we know, we get side don't know is equal to side known divided by the trig function of the angle. And that's literally every trig function, every trig problem ever that looks like this. Let's look at another one of these. Suppose we have something that looks like this. Suppose we have a tiny little triangle here. Oops. Let's try to draw this a little more carefully. Boop. Really tiny right triangle. Pretend that's right. My art skills are not magnificent. This side's 15. And the hypotenuse is the thing we want to know. So, okay, what is side we don't know divided side we do know? And we're told this angle here, I believe, is the side we're given? Yep, is 15 degrees. So we want side we don't know over side we do know. So that's hypotenuse over opposite. So we look to our list. Hypotenuse over opposite is cosecant of x. So cosecant of x is equal to, sorry, cosecant of 15, I should say, degrees, is x over 15. I believe both of these are 15. I apologize, I'm doing this from a teeny weeny picture of somebody's homework. I don't know, that's like they asked me a question based on. So 15 times cosecant of 15 is equal to x. And then you look at it and you say, that's great, but I look at my calculator here, and I do not see a cosecant button. I see a sine button, I see a cosine button, and I see a tan button. And be very, very careful here because there's a trap. The trap is you look at the little blue lettering above the sine button and see, oh, sine to the minus 1. That means 1 over sine. No. This is a real problem with notation that we use for trig. It's terrible notation, but unfortunately it's been used for a couple hundred years now, so we're kind of stuck with it. Sine to the minus 1 means the inverse of the sine function. That's the arc sine. If I type 15, oops, I forgot, this is if I go second sine and get sine to the minus 1 of 15, that is not saying what is the cosecant of 15 degrees. What that is saying is, give me the angle such that sine will be 15. And since sine is never 15, this will probably just give me an error if I try to compute it. Yep, error, domain, error, help. So how do I get sine of 15 degrees? Well, I can say, what you can do is I can say, if I have a cosecant, cosecant is 1 over the sine, right? Because sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So what I do is I say, let's take the sine, which I know how to take, 15 degrees, and then use this x to the minus 1 button. And that will give me 1 over, that will give me 1 over the sine of 15 degrees, which is the cosecant. And then just as before, I need to multiply that by 15. That gives me my answer, 57.9. So this long side is in fact, the hypotenuse here rather, is in fact 57.95. So unless you've got an awful lot of digits, you're probably just going to say 58.0. And that's how to get that side. This is how to do every problem like this. This is Nighttime Mathematics Radio. See, do we have any more questions people have been asking? No new questions on Twitter, so I think it's time to end the show. Well, everybody, at this point, we'll be running the show every weeknight, 9 p.m. Pacific, from 9 p.m. till we run out of questions. Tonight it was short because we only got one question. But we'll be running the show every weeknight from now until June 12th. And June 12th is the end of the academic year, at least locally. So I'm going to, at that point, I'm going to stop doing the show nightly and start just posting pre-recorded episodes periodically. But for the moment, in this strange world where all the math classes are shut down, but the homework goes on and on and on, keep posting the questions, keep doing the math, and stay safe, everybody. I'll see you tomorrow night.